Okay, here we go. Solving problems with the 5D process. Now, when I first looked at this, I was like, oh my God, what is the 5D process? It looks so complicated. This is a really good way to problem solve and to just think of what would be a reasonable answer, right? So before declaring any algebra or algebraic formulas or anything like that, we're just kind of guessing and checking, and that's where we're at. Okay, so take a second, underline what you think is important, read through it, try and understand it yourself, and then we'll go through it together. Perfect. Okay, so this is what I would have highlighted. So there's a small part, there is only a small part that actually gives the description of it. And then you just kind of have to go in through the example to look. So take a second, copy this down, right? So the first step you want to do is describe and draw it. Second step is define. Third step is to do it. Fourth step is to decide it. And fifth step is to declare, okay? And what we're talking about is describe and draw is make a picture, right? A lot of times these word problems, if you make a picture, it'll help you see what the math problem is looking for, what you're trying to figure out, right? And describing it is taking out what is important from this problem. A lot of these problems have a lot of what I call foo-foo, which is like extra stuff, that story behind it, giving you a situation, trying to paint a picture. But when you describe it, you're trying to pick out what is important in this problem, right? And then defining it is being able to figure out, test out your options, right? To be able to pick a number, what you think would be correct. Doing it would be testing it out. Deciding it is deciding whether you got it correct, whether your answer is too high, whether your answer is too low, and then being able to narrow it down from there. And then declaring it is being able to either tell the answer, figure out the formula, all that good stuff, okay? Okay, so in the problem, for the example, the base of the rectangle is 13 centimeters, 13 centimeters longer than the height, right? So I'm going to take this. They described it, the shape is a rectangle. We're looking at the perimeter. That part, I would take the important parts, right? So we have, and I'm going to underline this, base is 13 centimeters longer than the height. And what I would do is I would label my picture. So if my height is some number, if I take X, my base is 13 centimeters longer than that. So I'm going to take that number and I'm going to add 13, right? What else do I know? Perimeter is 58 centimeters. So perimeter is 58 centimeters. And we know that to find the perimeter, you add all the sides, right? So taking all the sides and adding them together. Cool. So they picked the first trial. So we have the height, the base, right? In their definition, what they're trying to describe to test it out, right? So the height and base. If they use 10, this is the first test. If they use 10, you don't have to write all this down with me as I'm writing. So if they use 10 as their first example, the base is 13 centimeters longer. So I've got this plus 13. That means my height is 10, my base is 23, and they found the perimeter, right? So being able to add all the sides together, or you know that there's two bases right here, 1, 2. There's two heights, that's this one, and this one, right? So that's where they get these two from, okay? So 2 times 23 would be 2 times my base, 2 sets of my base. 2 times 10 would be 2 sets of my height, and they found that the perimeter was 66. Now, in the problem, they tell us that this perimeter is 58 centimeters. So this means that it's too high. You are deciding that your guess was too high, right? And then what we do is we keep going, right? So since it's too high, the next step, you take a lower number. So they choose 7. You could choose 9, you can choose 8, you could choose whatever those, like you could choose 1, but again, you're using your brain to figure out what would be a good guess. Okay, so same thing, and then you do the same thing over again. Your new guess is 7, right? And then you take 7 plus 13. 13 is the base, which is 13 centimeters longer than the height, right? So now your new base is 20, right? 2 sets of your base, 2 sets of your height. This gives you 54, but you're trying to find 58. So this is too low, right? And then trial 2, so you need to find something in between. I would choose either 8 or 9. Same thing. Your height, your base is 13 centimeters longer, so this is your new base. 2 sets of your base, 2 sets of your height, finding the perimeter, and then you know it's correct, right? So your declaration, what you declare at the end, is that your base is 21 centimeters, the height is 8 centimeters, because that's what it's asking for. So when you declare, it says find the base and the height of the rectangle. So what you declare is the base is 21 centimeters, the height is 8 centimeters. Okay, let's go through an example and we'll do it together. Okay, so take a second and copy this example down. So a box of fruit, let me move this down. A box of fruit has 3 times as many nectarines as grapefruit. Together, there are 36 pieces of fruit. How many of each type are there? Pause the video, or I'll pause it for you. Copy down the example, and I want you to describe and or draw it. Well, you're supposed to do both, okay? Okay, so here's what I would have described, the most important parts, right? So you have 2 parts. Actually, use a different color. You have 2 parts, right? So the first part, bullet point, is that the box of fruit has 3 times as many nectarines as grapefruits. What that means, if I want to find the nectarines, I take the grapefruit and I multiply it by 3. So 3 times as many grapefruit. Right? And then when you think of that, sometimes you'll think 3 times the nectarines, right? So 3 times as many nectarines as grapefruit, but you want to figure out which one has more, right? So in this situation, 3 times as many nectarines as grapefruit, you're going to have more nectarines, right? So when I take 3 times the grapefruit, that will give me what my nectarines are. The next piece that we have is there's 36 pieces of fruit. So if I take nectarines and I add it to my grapefruit, this will give me 36 pieces total. Now I'm preparing you guys right now to, what's it called? For algebra, for when we make our equations for it. Take a second and draw. I'd like to see in class what you guys draw for this situation. Yeah. Okay, perfect. So then we're going to draw this. You might need to write smaller for this. Right. So our columns, define, do, decide. The declaration is going to be at the end, describing and drawings at the beginning. Okay, so take a second, copy this down. Right. In our defining, we have 2 options. We have the number of grapefruit, and then we have the number of nectarines. Right? And remember, whatever the grapefruits are, we multiply it by 3. Okay? So, picking a number. Right? I wish I could survey you guys to figure out what number it is, but I'm just going to go ahead and throw out 10. If I have 10 grapefruit, I can say that my number of nectarines is, what is it? 10, it's 3 times as many grapefruit. So 3 times 10 would be 30. Right? Remember, you're just going to multiply it by 3. Then we do it. It says the nectarines and the grapefruit equal 36. So if I take my nectarines, I take my grapefruit, and what does this equal? This equals 40 pieces of fruit total together, right? So when I look at this, I decide, right? Is 40 what it is supposed to be? Is it too high? Is it too low? I'm going to decide that this 40 is too high, or 40, right? Write my answer. Okay, so then, since it's too high, I pick a lower number. So if I go and do 5, right, for my next one, 5 for my next one, I do the same thing. There are 3 times as many nectarines as our grapefruit, so 5 times 3 is 15. I add them together, so I'm going to go ahead and take 5 plus 15 nectarines. What does this equal? This equals 20, right? And what did I want my total to be? I wanted my total to be 36, so this is too low, right? This is 20. Finding something in between, right? So I'm just going to pick another number. I've already solved this ahead of time, so we're going to go ahead and you just keep going, right, until you narrow it down, right? This is kind of like a guess and check, but this one is 9, if I multiply it by 3, this gives me 27. 9 times 3 is 27. I add them together. So I take 9 plus 27 will give me 36. Oh, sorry. And that is correct. Right. So what I do is I declare there are 9 grapefruit and 27 nectarines. So always answering the question that they asked, right? It says, how many of each type are there? There are 9 grapefruits, there are 27 nectarines. And I want to show you one more thing, the algebraic way to do this, right? So if I had my nectarines, I don't know what it is. If I don't know, I use a variable, right? So I use X or any letter you want to use. You could use G, right? My nectarines, all I do is I times 3. So this would be 3x, right? And I know that my total of, when I add them together, I will take x, I will add my 3x, and my total has to be 36. So this is my formula that I'm using for this. And when I solve for x, I will discover that x equals 9. But I think that's a later date. Okay? We're totally going to do practice in class. But yeah.